Okay, we've been talking about permutations and counting and organized counting, and that involved n of a, it involved n of s, but of course we're working towards n of a over n of s, which is p of a. So we've been doing all kinds of different counting to get to the point where we want to find the probability of events happening. Okay, this is a unit about, we're going to go over strictly examples, because we already know what permutation is, we already know what probability is, we already know different techniques for counting. Now we're going to bring all together. Okay, so let's talk about example 1. And for all of these, I want you to try them yourself and to really think them through. Okay, if you're not sure how to do it, go to the basics. You could always solve almost every problem with, a tree, but we're not going to bother going that route. But if you need help understanding a problem, going with a tree diagram works sometimes. So our first question, software for generating multiple choice tests randomly assigns A, B, C, or D as the correct answers to a multiple choice test. On a 10-question test, what is the probability that all 10 questions have C as the correct answer? So what's the probability that it all has C as the correct answer? So, there's many ways we can do this. And one of the ways is we can use the theoretical probability, and we can find the number of ways that we get all C's over the number of total ways that the software can randomly generate combinations of correct answers. So what is NS? Well, we have 10 possible squares, and there's 4 possibilities for all of them. Basically, it's 4 to the power of 10. We multiply each one. So if I was to draw a tree diagram, it'd be 4 for the first choice. And then this would have 4, and each of them would have 4 times 4, and that's how we did that. Hopefully we're not drawing. We don't need necessarily to draw tree diagrams. So 4 to the power of 10. This is good, right? And then how many ways can they all be C's? Well, there's only one way that can be C. One way, etc. So the probability of all C's is 1. We got that 1 from there. Over 4 to the power of 10, which is a pretty small number. Okay, it's basically move the digit 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 0.00, very small probability. In fact, it's better to think of it as 1 in a million almost. Okay, using independent event probability. So look at each question. Ask yourself, what is the probability that it's a C? 1 out of 4. Multiply that by, this is an independent event, we multiply it by 1/4. So it's basically 1 over 4 to the power of 10, and mathematically you see how that's 1 over 10, or we can say 1 to the 10 over 4 to the power of 10, which is exactly the same thing. We end up getting the same answer. Okay, so I want you to try this one, as usual, but you can pause it and come back, and then I want you to look at the answer. I'll just give it to you. A street illusionist asked 5 people to each secretly write a number between 1 and 100 on a card. Now, incredibly, they all write the same number. What is the probability of this occurring? Now, you can do it 2 ways. Theoretical probability, where you count NA over NS, or you can calculate probability of the first number times probability of match, part 2, times etc., etc. for 5 people. Okay, try and do that. Pause it and take a look at it, and then yeah, we'll take it up right away. All right, so we have 5 possibilities. You'd think that the probability of them selecting the same number is 1 over 100 times 1 over 100. But in fact, that's not the case. Okay? What we have to, and I say discuss, so when we're in class, we'll discuss it. But the truth is, the probability of selecting the first number is 100%. The correct number. The first person who chooses the number can choose every number, any number. So you basically don't count it. The first person picks that, and then these 4 are going to have to match that first number. And what is the probability that this matches? It's 1 over 100. Okay, so the probability of this person matching what the first person chose is 1 over 100. Okay, so it's a little bit of a trick, which is 1 over 100 million. So that's the chances of it occurring. Okay. Now, how would you do this? Another challenge for you to try is, how do you do this if you wanted to do the theoretical probability, NA over NS? Well, obviously, let's see. NS is obviously 100 to the power of 5, right? Because this person can choose 100 numbers. This person can choose 100 numbers independently. They all can choose 100 numbers. So 10 to the power of 5. But NA, how many ways is there to match a number? Well, I can match 1. I can match 1. I can match 2. I can match 3. I can match basically 100 numbers. So there's 100 ways. So that's why it becomes 100 over 100 to the 5. So this 1, 2, 3, 4, and 5. So that's why we cross out that, and we got 1 over 100 million. Okay, so next example. 5 names are on a waiting list. What is the probability that they will be in alphabetical order? Now this is very similar. Pause it, try it yourself. Since you cannot choose a person twice, we can use factorial. So, how many ways are there to choose 5 people? 5 factorial. What is the probability that they'll be on the waiting list? There is only one way to list them in alphabetical order. Any other way would be out of order. So, probability all in order is 1 over 5 factorial, which is 1 over 120. Now let's try doing it using individual probability. Here we have 5 people. What's the probability that this person will be the person it's supposed to be? Well, that's 1 in 5. And this will be 1 in 4 of the remainder. And the probability one of them belongs here, that'll be 1 in 3, 1 in 2, and 1 over 1, which is 1 over 5 factorial. Because we multiply all of these, right? Multiply the denominators, multiply the numerators, and we get 1 over 120, which is the exact same answer in a different way. Okay, so what is the probability? Example 3. What is the probability of selecting a king, then 2 queens out of a deck of 52 cards? Okay, so I have to select 1 king and then 2 queens. So probability of that happening is number of possible outcome over number of ways A can occur. All right, so we have 52, choose 3 ways to select 52 cards, so to select 3 cards from 52. And if we plug that into our calculator, we get 132,600. And then, what's the probability of selecting 1 king? How many ways can we select 1 king? Well, we can select 1 king in 4, choose 1 way. Right? 4 ways. What's the probability of selecting 2 queens? How many ways can we pick 2 queens? Well, we can pick 2 queens in 4 choose 2 ways, right? Which is, well, if we do the math, like, let's just show the math. 4 factorial over 4 minus 2 factorial, which is equal to 4 factorial over 2 factorial, which is equal to 4 times 3 times 2 times 1 over 2 times 1, which is 4 times 3, which is 12. Let's clear the markings. Now, for every way of picking a king, there are 12 ways to pick 2 queens. So that's 4 times 2. The probability of picking a king and 2 queens is 4 times 12, right? So every time I pick 1 king, there are 12 ways I can pick 2 queens. So it's 4 times 12, which is 2 over 5525, which is a very small number as well. Okay? Now, alternatively, we can say, well, the probability of selecting a king. What's the probability of selecting a king? 4 over 52. This is the same question done with independent events. Or actually, they're dependent events, actually, because it changes. The probabilities are going to change. Multiplied by, what's the probability of selecting a queen? Well, there's 51. Ooh, that's not right. It should be 4 out of 51, right? Because there's 4 queens out of 51. Yes. What's the probability of selecting another queen? There we go. It's actually 3 out of 50. Something's wrong with my slides. Okay, so there we go. I fixed it right here. 4 times 4 times 3. So let's clear some of this stuff. 4 times 4 times 3 over 52 times 51 times 50. Okay, that's 2 over 5525, which is exactly what we got in the previous example. Now we compare that to the previous method. Take a look at that. Whoops. It's 4 times 3 over 52 choose 3 is 52, 51, and 50, which is exactly that. Okay, where'd we get these numbers from? That's where we got these numbers from. Okay, convince yourself that it's true. Now, if I want you guys to try, I'll let you guys try this. What is the probability that Kylie selects 3 aces followed by 2 jacks? What is the probability that Kylie selects 3 aces followed by 2 jacks? Well, we can try it. Oh, I did it over here. So NS. How many ways are there to pick 5 cards? 5. 52 choose 5. And how many ways are there to select 3 aces? Well, there's 4 choose 3 ways. And how many ways are there to pick 2 jacks? Well, there's 4 choose 2 ways. And these are independent, really. Okay? Sorry, they're mutually exclusive. Picking a jack is different from than picking... but that's not what I meant to say. I meant to say that for every way to pick 3 aces, there's 2 ways to pick 2 jacks. And for every way to pick 2 jacks, there's this many ways to pick 3 aces. Well, let me say that one more time. So for every way I can pick 3 jacks, there's this many ways to pick 3 aces. That's why we have to multiply. Okay, so that ends up being this 4 times 3 times 2 is 4 choose 3. And how do we know that? I'll just do the math right here. That's 4 factorial over 4 minus 3 factorial, which is equal to 1 factorial. 4 factorial over 1 factorial, which is 4 times 3 times 2. Which is basically 4 factorial. It's the same thing. And this 4 choose 2 is 4 times 3. And 52 choose 5. Well, there's 5 numbers to go from. That's another way to look at it, right? We go from 4 and we have 3 numbers. We go from 4 and we have 2 numbers. And we go 52 and we have 5 numbers. Okay. And we could do it the theoretical probability way as well. Where, what's the probability of selecting the first ace? 4 over 52. Once we select that, there's only 51 cards and there's 3 aces left. So there's 3 out of 51 chance. And then once we select that, there's one less card and one less ace. So it becomes 2 over 52. And so far we have that there. If you notice, that's the same. And that's the same right there. And now to pick 2 jacks, well, you got one less card, 49 cards, but you have 4 to choose from. That's where this 4 comes from. And then we have one less to choose from, but we have 3 jacks to choose from, and that's where that comes from. Oops. Discard. Whoops, let's go back. And the probability of choosing is that. Notice that they are exactly the same. Okay, and don't worry about that. All right, this will be in the next video.